I'm Andrea Batch, and I'll be presenting on Wizualization, a hard magic visualization system for immersive and ubiquitous analytics, which I co-authored with Peter Butcher, Panagiotis Ritsos, and Niklas Elmqvist. While I'm sure people who are interested in this topic will already be familiar with immersive analytics, our system, per the title, also concerns itself with ubiquitous analytics, analytics anywhere, anytime, across any network device. Immersive and ubiquitous analytics represent part of a shift away from the desktop in visualization research. And with that shift, there's a little more freedom for creativity in exploring a breadth of interaction modalities for visualization as explored by Lee et al. In 2012 and Roberts et al. In 2014. And not just creativity. One recurring theme that's appeared in our own and in others' work has been that participants of empirical evaluations of immersive analytic systems have commented on the experience having been fun. And fun, for me personally, evokes the notion of games and fantasy, and thus magic as a theme arose as something relevant to IA and UA design. A theme that has a common thread with both IA and UA in game systems of involving spoken incantations and wriggling fingers, gestures and speech, or to borrow from Dungeons & Dragons' magic system, verbal and somatic spell components. To keep things serious and practical, we do frame our motivation in the context of vignettes of analytical fieldwork in our paper, where we do at least borrow stylistically from Dungeons & Dragons' player handbook. So let's talk about the system. Wizualization is really composed of 4 or 5 components. And one of these is optimancy, the grammar of graphics, or GOG, we developed specifically for multimodal cross-device interaction. Much like many GOGs, optimancy takes JSON configs, or specifications, which are constructed by the user in the rendering system, as I'll discuss momentarily, and returns React components to the user via its optimancy R3F extension, which are then rendered to the scene in the visualization interface. A wizard wouldn't be a wizard without a spellbook, and in our system, we use the spellbook metaphor to describe a component that serves 2 purposes. First, as an immersive code notebook interface that presents the user with components of the optimancy specification that they've generated as part of the analysis they're performing during their session. And second, as a compendium of gestural and spoken primitives, or basic commands that we thought were essential for the system. And we recorded these primitives in English and American Sign Language, and they can be used to create and group views and modify the visual marks and channels of the views that they've created. I was a little hand-wavy about the number of components. Recall I said 4 or 5. So calling the multitude of different device types that can use the system arcane focuses is a little hokey, but the point of doing it is to highlight how central ubiquitous analytics is to our design principles. The devices are all linked or woven together via a rooming system with our server-side signaling component Weave, which also stores the user's sessions and any spells they create during those sessions. Any number of wizards, users, or wizards can join a visualization room and share the URL of that room with the other wizards who can also join. Virtual objects created by wizards in the room are rendered to all devices connecting that room, and each wizard may access the room using any number of devices, be it an augmented or virtual reality head-mounted display, a mobile device, or a desktop as a spectator. Wizualization is the rendering system, which imports optimancy and spellbook, recognizes speech and gestures, and matches them to the primitives in the spellbook or stored in Weave. Sends Weave updates to be propagated across all devices, or arcane focuses, connected to the room by Weave, and generates optimancy specifications that use optimancy R3F to create React 3-fiber components, which it renders, along with the spellbook menu, to all arcane focuses in the room. So to reiterate, Wizualization imports optimancy and spellbook, recognizes speech and gestures, and matches them to the primitives in spellbook or stored in Weave, using Levenstein edit distances for spoken command matching and dynamic time warping for finger pose or gesture matching. sends Weave updates to be propagated across all devices connected to the room by Weave, and generates Optimancy specifications that use Optimancy R3F to create React 3-fiber components, which it renders along with the spellbook menu to all arcane focuses in the room. So let's take a look at it. Any number of devices, or arcane focuses, can be connected to a web browser room at optimancy.com, and interactions are propagated across arcane focuses via Weave, our signaling server. In this example, we're using a HoloLens 2 for mid-air gestures and a smartphone for spoken commands. Once signaled, our rendering system, the eponymous Wizualization, matches the user's input with stored system commands, and generates a specification for Optimancy, the grammar we wrote for the system, and its React 3-fiber interpreter, Optimancy R3F, returns a React 3-fiber visualization component, color, which is then rendered to the scene. Spellbook, our extended reality analytical notebook, presents the users with each step of their workflow as reflected within the element of the Optimancy grammar specification that has been updated by the spell that they've cast. Spellbook, in addition to returning spellblock React components to be rendered, also contains a number of basic pre-recorded spell primitives that we consider essential, which are shared across all rooms. These primitives each correspond to a spoken word in English, as well as a sign word in American Sign Language. Table 1 in the paper provides more detail on each individual primitive. Also shown on the left-hand side of Spellbook's menu interface, which, naturally, takes the form of a book. The right side of the book presents the user with a variable selection menu on the top, and a list of spell blocks on the bottom, which can be expanded for a stacked view or an unfolded view of each block. As a consequence of this means of linking devices, Wizualization supports synchronous collaboration within a room. In this example, 3 users, 1 remote and 2 co-located with each other, across 2 different countries are able to create and share views of the same dataset with each other in real time. We use this metaphor of magic in large part because the primary input modalities of mid-air gestures and spoken word, alongside that of direct manipulation with objects in the view, were both motivated by an assortment of magic systems. With that said, magic has influenced a number of our design decisions, such as the use of glowing particles to indicate that the user's hands are being tracked for input, or, of course, our naming conventions. Wizualization uses dynamic time warping to match users' gestures and Levenstein edit distances to match spoken words or phrases, with recorded gestures and phrases stored either in Spellbook as gestural and spoken primitives, or persisting in Weave on an individual room basis. This allows for some error tolerance in matching the nearest word or gesture with the available commands. Axiom. In this instance, the closest word to axiom is axis. If the user gets an unexpected system response, or finds that they're not interested in a step in their workflow, they can revert their view to an earlier state with a direct manipulation of a spellbook block. So I've done a few accidental casts here. That one was on purpose, that was axis. So what I'll do is I will delete them starting with this one. And that should set it back to a single axis with color. So, having watched the demonstration, let's lay out the general workflow. Once connected to a room with an arcane focus, the user casts a spell. The recognized spell is sent as a signal to Weave, which is returned to all devices, which Wizualization, running on those devices, converts into a spell block that gets added to the Optimancy specification, which is used to render everything in the room, supporting collaborative cross-device or ubiquitous analytics. And with that, we're about out of time, so I hope you've enjoyed the talk, and please check out our paper for more detail.